Hello everyone, my name is Adarsh Kashyap and currently I am pursuing my bachelor's degree in computer science and engineering from Ambedkar Institute of Technology for Handicap and I am in my final year. Currently I am working as an embedded system intern at Emertxe and today I am here to represent my project on microwave ovens revolution that was assigned to me as an intern at Emertxe. So let's get started. So let's talk about what I have learned during the internship. So first we have learned the introduction to C, then we have moved to the conditional statements, loops and operations. Then we move to more advanced topics like array and pointers, functions and strings, storage classes. Then we have learned about the introduction to embedded systems and microcontrollers. After that we have learned the IDE, the PiximLab, XC compiler, then we have moved to introduction to various peripherals of PIC16F877A and then we are learn about the interfacing various peripherals of PIC16F877A. Then I have give the multiple quizzes and also I have attended the Disha workshop. So moving forward, let's talk about the contents that we are going to discuss in this video. So first is what is the microwave oven, then we are going to learn about what is the requirements and what is embedded system, the difference between the microcontroller and microprocessor, what is Pixim Lab, CLCD, matrix keypad, ISR, timer, and finally we are going to see the project implementation. So let's get move forward. So, introduction to microwave oven. A microwave oven is a kitchen appliance that uses microwave radiation, especially microwaves, to heat and cook food quickly and efficiently. Microwave ovens typically come with several cooking modes or settings to accommodate different types of food preparation. We are going to implement four modes as follow. First one is grill mode, second one is grill mode, first one is micro mode, second one is grill mode, third one is convection mode, and the fourth one is start mode. So what is microwave mode? Like quick and efficient heating. Like microwave mode is the standard mode used for quick and efficient heating of food. It is particularly effective at reheating leftovers and heating beverages in a matter of seconds. Uniform cooking. Microwave ovens can provide relatively uniform heating throughout the food. Although it may not always brown or crisp the food's exterior, it is excellent for evenly heating dishes without the need for added fats or oils. Grill mode. Browning and crisping. The grill mode is basically used for browning and crisping. So grill mode uses a heating element on the top of microwave to brown and crisp the top of dishes. It is a perfect for creating a golden crust on casseroles, melting cheese, and achieving a grilled texture on certain foods. Versatile cooking. Grill mode allows for more versatility in cooking as it combines microwave heating with grilling, giving you the option to prepare a wide range of dishes like sandwiches, pizzas, and so on. Convection mode. Baking and roasting. Convection mode utilizes a fan and heating element to circulate hot air, making it ideal for baking cookies, cakes, and roasting meats. It provides even cooking and browning, similar to a traditional oven. Crispiness and textures. Convection microwave are known for producing dishes with a crisp exterior and tender interior, enhancing the texture and flavor of various recipes. Start mode. Basic heating. The start mode is the default setting in many microwaves and is used when you want to heat or cook something without using any specific cooking mode. Simply input the desired time and power level, then press start. Customizable. Start mode is highly customizable, allowing you to manually adjust the cooking time and power level based on your specific cooking needs. It is a versatile option for various cooking tasks. Requirements. So we need to make that project, so we are required like id like mplab xid xCAD compiler to compile the code, pixim lab to stimulate this. So in pixim lab, like we need pic 16f877a 16 cross 4 clcd tactile switch mkp timer 2. So what is embedded systems? Like the definition and purpose. Embedded system are a specialized computer system designed to perform dedicated functions or tasks within a large system. They are embedded into various devices and appliances ranging from consumer electronics, example smartphones, washing machines, televisions, to industry machineries, example CNC machines, automobile control system. The primary purpose of embedded system is to control, monitor, and manage the operation of these devices efficiently and autonomously. Let's talk about the characteristics. Real-time operation. Many embedded systems operate in real time, meaning they must respond to inputs and perform tasks within strict timing constraints. This is critical for appliances like automotive safety systems and medical devices. Resource constraints. Embedded systems often had limited computing resources, including memory, processing power, and energy. Designers must optimize software and hardware to work within these constraints. Reliability. Reliability is a paramount in embedded system, especially in safety critical applications. Failure can have serious consequences, so extensive testing and redundancy are overcome. Integration. Embedded systems are tightly integrated with the hardware they control. They may include microcontrollers, microprocessors, sensors, and communication interfaces. Customization. Embedded systems are typically custom designed for a specific application or device, allowing the precise tailoring to meet the requirements of the task at hand. So the components of the embedded system are input devices like processor, having processor, power supply and rest oscillator circuit, timers, interrupt controllers, program and memory management, social communication ports, pallet ports, system application specific circuits are connected, and there is a output interfacing where we will get the output. Let's see the difference between the microprocessor versus and microcontroller. Unit ALU, CPU, and registers. And in microcontroller, there's CPU, I/O ports, counters, timers, RAM, ROM. Let's see more about that. So microprocessors are widely used in computer system, while the microcontroller is widely used in embedded systems. It has only a CPU embedded into it, and in microcontroller it has a CPU, a fixed amount of RAM, ROM, and other peripherals all embedded on it. In case of microprocessor, we have to connect all the component externally, so the circuit becomes large and complex. As all the components are internally connected in microcontroller, so its circuit size is small. It consumes more power, and microcontroller consumes less power as compared to microprocessor. It has a very less internal register storage, so it has to rely on external storage. So all memory operations are carried out using memory-based external commands, which results in high processing time. While in case of microcontroller, it has many registers, so processing time is less. That is the difference between the microprocessor and microcontroller. So move forward. That is the architecture of the Pixing Lab. So it has the RS-232 LEDs, buzzer, digital keyboard, SSDs, matrix keypad, CLCD, ADC, temperature sensors, RTC, and GPIO. So all these are connected in that Pix 16F877A, and all this is the structure of that. So what is the CLCD? CLCD typically stand for character LCD or character liquid crystal display. In Pixim Lab there are two types of display. First one 16 cross 2 display and second one is 16 cross 4 display. It displays the sky character and some special characters. There are two types of communication modes, 4-bit mode and 8-bit mode. Tactile switch. It is a switch whose operation is perceptible by touch. This switch is used to select the mode of operation and to enter the temperature and time in our project. These switches produces bouncing effect when a switch is pressed, and this look like that. The switch. Talk about the matrix keypad. So first one is a grid structure. Matrix keypad have a grid of buttons organized in rows and column. Second, digital output. When a key is pressed, it creates an electrical connection, providing a digital output. Cost effective. They are compact, cost effective input devices used in various electronic applications, using including the calculator and remote controllers. So, what is interrupts? An interrupts in a communication process set up in a microprocessor or a microcontroller in which an internal or external device requests the MPU or MCU to stop the processing. Then the MPU or MCU acknowledges the request and attends to request, goes back the processing where it was got interrupted. ISR, interrupt service routine. An interrupt service routine is a software routine that hardware invokes in response to an interrupt. ISR attends to the request of an interrupting source by clearing the interrupts flag and should have registered contents that may be affected by the code in the ISR. It must be terminated with the instruction RETIE. When an interrupt occurs, the MPU completes the instruction being executed, then it disables global interrupts, enables and places the address from the program counter 1 the clock. So, timers. Timer is an important application in my embedded system, which is a default peripheral which maintains the timing if an operation is synced with a system clock or an external clock. It has many applications such as measuring time and generating delays, etc. Timer or counter is a software designed to count the time intervals between the events. Resolution, which is also called register width, 8 or 16 bit, etc. Tie is referred as a change from one number to another number. It may be up counter or down counter. Quantum, which depends on the system clock setting, is a measure of time which is responsible for the tick scaling, may be pre-scaler or post-scaler. So let's start the demo. So there are the operations function like operation having cooking mode display, and then after that there is a start mode, after that micro mode and the grill mode and convention mode. That's the function to print the power on message. It is used to clear the display screen. Set time function is used to set the time in the timer. Timer display the timer. Set time temperature is used to set the temperature, and there is a condition like if the temperature is greater than 250 then it will show the message of invalid temperature. So now let's build the project. So you can see that the project was successfully built. As we have built the project, so we are going to open the Pixim lab and load the hex file here. Like you can see that the Pixim pic16f877a, that was our heater cooler, that is a heater. And let's load the hex file. Select that file, open it. Power 900 watt. Now you can set the time. So we have entered 10 seconds. When you press the start, then it will clear. So again we will going to enter and press hash to enter this. Now you can see that the cooler has started and time also runs with, see this. As you can see that when we press the 5, the fan and the timer both will be stopped, and we are going to press the 4 to resume this cooking time up. As the timers and the cooking time will up. Now let's see the grill mode. So as you can see that the oven has started. Now the buzzer is beeping as the cooking time is up. Now let's move to the convention mode. Here we have to enter the temperature. As you see that when I have entered the 500, then it will show the invalid temperature, as we have mentioned the temp condition there. So we will write 100 degree. So time remaining is 50 seconds. So just wait for that. Now let's check the start mode. So as we press then start mode, then it will automatically set the time for 30 seconds and the oven has started. When we press the 5, the cooler and the timer both will stop, as you can see that. So let's go and resume this. The cooler has started, as you see, and the timer also started. So that was the my project demo video, and that's all from my side. So thank you for watching till now.